Assalamualaikum and very good morning to all evaluators. My name is Muhammad Fadil Hazman bin Zulkifli, metric number S55983. My supervisor name is Prof. Madya Dr. Nuraniza binti Harun. My final project is the synthesis and characterization of polyacrylic acid PAA nanoparticles via emulsion polymerization technique. The introduction for my final year project. The nanoparticles polymers such as PAA nanoparticles have been widely used in the research study. The scope of my project is to synthesize the PA nanoparticles via emulsion polymerization technique. This technique will involve acrylic acid as hydrophilic monomer, sodium disulfide as anionic surfactant, potassium persulfate as soluble initiator, and water as dispersion medium. The formation of PA nanoparticles will be investigated at different concentrations for surfactant, as well as the characterization of PA nanoparticles will be performed spectroscopically and microscopically. For the problem of statement, the synthesis of the nanoparticles usually involves either complex methods or expensive machines. This is due to many processes that include reducing the original substance, while the technique does not involve machine, usually hazardous because of the toxic gas released by the acrylic acid. For the significance of study, to obtain a good quality and stability of nanoparticles without involving dangerous and costly method, provide more information and better result of PA nanoparticles, and encourage subsequent students to use this existing study as a reference material. For my objectives of study, to synthesize polyacrylic acid PA nanoparticles via emulsion polymerization technique, to investigate the effect of surfactant concentration on the size and formation of polymer nanoparticles, to characterize in PA nanoparticles spectroscopically and microscopically using Fourier transform infrared spectroscopy (FTIR), tomographic analysis (TGA), and scanning electron microscopy (SEM). For the methodology, we use the reactor that consists of 250 ml 3-neck round bottom flask with magnetic stirrer, a reflux condenser, nitrogen gas, inlet, and thermometer. For the materials that are used in the mixed method is acrylic acid monomer, which is the simplest unsaturated carboxylic acid. Sodium disulfide SDS as an alphaphilic molecule which is commonly ionic type surfactant. Potassium persulfate KPS is a soluble inorganic compound which also categorized as typical initiators. Water is employed as the main dispersion medium to aid effective heat dissipation during nanoparticle formation. For the emulsion polymerization technique, the acrylic acid 2 ml will be added into the mixture of distilled water 10 ml and sodium disulfide at different concentration, which is 5 millimolar, 8.2 millimolar, and 9 millimolar respectively in the reactor. Set in the temperature room, for 15 minutes nitrogen gas will be bubbled through the reaction mixture. The polymerization will be taking place in the heat metal at the temperatures of 80 degrees Celsius and stir at 120 rpm. This process will be initiated by the addition of aqueous potassium persulfate 0.1 gram solution. The polymerization will be carried out over a period of 3 hours. Characterization of PA nanoparticles, we will use Fourier transform infrared spectroscopy (FTIR), which is used to identify fractional group in the PA nanoparticles, scanning electron microscopy (SEM) to provide the resolution image of PA nanoparticle surface, and tomographic analysis (TGA) to use to determine the thermal stability and fraction of volatile PA nanoparticles. This is the result as I progress 5 millimolar SDS, which is below CMC, and 8.2 millimolar SDS equivalent to CMC. The result obtained for both concentration is in the gel form. For the 5 millimolar SDS concentration give a transparent gel liquid, while the 8.2 millimolar SDS concentration give a transparent gel liquid with a few transparent solid gel. This is FTIR result for acrylic acid monomer that will be used as a reference. There are 5 peaks to show the functional group in acrylic acid. 3029 is a functional group of OH, 1684 C double bond O, 1612 C double bond C, and 1426 is CH, and 1043 is CO. For the first sample, PA nanoparticles 5 millimolar SDS below CMC, there are 4 peaks that can be determined, which is 3308 for the functional group OH, 1624 C double bond C, 1550 CH, and 1043 206 is CO, while the pure nanoparticles 8.2 millimolar SDS equivalent CMC, the peak is too broad, but there are 5 peaks that can be determined, which is 3291 for functional group OH, 1692 C double bond O, 1630 for C double bond C, 1477 CH, and 1324 for CO. Next, this is the Gantt chart that will be used for my final year project progression. That's all from me. Thank you.